So my talk is about the journey towards autonomous operation. So at the beginning, I will talk about autonomous operation and how we see autonomous operation. And the second part would be more dedicated to the lessons learned and how we see the path going forward. So as we see operation today, actually the people, or what we call SME, the subject matter experts, are the glue of the processes. And why is it so? It is because the network is pretty disconnected from the operation. Then network, service is defined in the network. It is thrown to the wall, I would say, and then it comes to the operation. Operation people have to face with many issues that you see, the importance of event, the impacts the events pose, the customer and its specific, profile, requirements, the package he has paid for, SLAs, priority, and so on. And we are talking, of course, about hybrid network, where, we have both PNF, VNF, and different type of the accesses. So basically, operations has to fill the role of somehow providing that quality of service, what we call quality of experience, without really knowing the profile and what was needed, the service intent of that service provided to the specific customer. And of course, everything is happening in reactive, resource-centered, not customer-centric manner. And now that we move towards 5G, and at this point of time, I would say it is not a pure talk, it is becoming a reality. It is, at least on the RAN side, that will come. We hear already about quite a few, at least 5G RAN-based deployment coming up this year and next year. A lot of new challenges are coming, and here I show some of those challenges. One of those is dynamic architecture, where actually service is not static. So, and once service is not static, then we have a connection between network and service, the correlation between network and service being lost. And the solution to that may be service-driven and to an autonomous solution, which support a widely dynamic environment. By the way, network slicing largely belongs to this, dynamic architecture aspects. The other thing is that we have a new KPIs to assure, and that also connects to network slicing in terms of, services that would require low latency, some other will require high bandwidth. Those requirements would be slice specific. Service would be, when we would decide which service to add to each slice, all this will happen dynamically. So assurance has to be provided according to the use case requirements and predefined KPIs. The other thing is network utilization. 5G network usage will vary widely between different applications. So one of the solutions for that would be effective optimization of network resources. And that would need to happen because actually, we all say that network slicing would resolve many issues, would provide a dedicated network to the customer, but dedicated network is also costly. And then you provide something costly, then you really have to assure that, resources are not just spent for nothing, but built it in a way that it is very effective. Now, search of services, of course, at least the expectation of 5G is to provide quite a few of new services, and that a new service would be very easy to deploy. Now, a new monetization models, and one of the things that I can mention here, which is currently being also discussed by 3GPP, is actually network slice as a service to enterprises. Something which did not happen before. What we have right now in the network, in pre-5G network, is only, subscriber-based charging. Now, what may happen with 5G is actually a different and new monetizations model when service or slice is provided as a service to enterprises, and that would require, again, a new update of IT systems, something which we haven't faced before. And of course, diverse ecosystem, disaggregated architecture, multi-vendors, cross-carrier solutions offering, and so on. And this would require continuous integration effort if we really want it to happen. Now, so this slide kind of, summarizing all the challenges and what we are facing currently and will face in the next years to come. So complexity, use cases, KPIs, the amount of vendors per specific deployments, dynamic architecture, all these things arise while there is a huge demand from the service provider on CapEx, OpEx, and manpower, service deployment, and all these things to go down, actually. So we have to see how we really achieve those two things, which, kind of see not that easy to achieve. And we believe that, really for that to be achieved, what we need is to stop looking on the service or on how service is defined in the network as something which is resources-centric and reactive approach, but really look on the service and do a proactive approach of continuous learning. And that would lead to the automation, of course. Now, that actually shows on the left side how today the new service is defined. So what you can see below is a different type of the accesses, backhaul, in RAN, and so on. And up we can see applications, different applications, and IT services. And when new service is defined in the network, it is usually a spaghetti of definition between IT and network and different types of application. And as service becomes more and more complex, this spaghetti would become, more and more impossible to really to be implemented. And that definitely would not lead to autonomous operation. So the solution that we see here is actually to define an abstraction layer in between network and IT operation, and that automated abstraction layer would be policy defined, of course, based on AI, software control, and that would actually maximize resource efficiency, because that layer would actually expose only service capabilities, and that would lead to something which helps to make the time of service definition shorter. As John was mentioning in the panel, as automation would lead to a shorter timeline of defining the service. We believe that such an architecture is actually a solution for that. This is on how we plan to achieve it. So basically, it all starts from service design. And the important thing here is that service design would not only include, the parameters for network automation and orchestration, but the important thing, it would include KPI for service assurance and management. So we can see it go in both directions, from service design to network automation and orchestration, and to service assurance and management. Now, then event happen, service assurance and management would feedback, would actually talk with network automation and orchestration, but important that it would also feed back to service design. So service design may actually be corrected as a result of the information received from service assurance and management. And this is how we may achieve actually intent drive assurance better. Now here on this diagram, Mark was mentioning actually that I also lead a use case subcommittee in ONAP in addition to my duties with MDOC. So in this diagram actually is taken from ONAP. We basically show how we see this process happening, the closed loop operation happening in ONAP. So at the beginning, of course, services defined, policies are defined, analytics are defined. Now, and distributed, of course. Then the services monitored. Now, log events are gathered. Now, the important thing is that at this point, there may be recommended changes which may lead to redefining a service, something that I was showing on the previous slide. And this way, actually, the ongoing real-time data feeds the system back to design. So service would be redesigned in a batch a day by information receiving from the real-time. Now, again, we are moving and we are mostly looking on 5G and how that would look, in the world of 5G. And of course, we would have a new different services with different accesses, disaggregated architecture, a new core. And there is clearly a need to provide it end-to-end service-driven automation from RAN, edge, core, up to the data centers with the different applications. Now, speaking of the technologies, and this is something which is known, we basically see 3 technologies which are evolving right now: virtualization, slicing, and edge computing. And of course, they all are connected. I cannot even, actually really differentiate between them, because, when you look on edge computing and, for example, efforts made by ETSI-MEC, then all their architecture is showing compatibility with ETSI and FV. Same for slicing, there is a lot of connectivity, and actually, again, if you talk about, ETSIs are the same, one of the major use cases which they define as slicing, virtualization, of course. All this technology present an opportunity for creating new services, but actually, they also, with those technologies in place, the definitions may seem as becoming more complex, so there is clearly need for providing end-to-end automation. Again, this is showing on the left side virtualization, slicing, and edge computing as a new technology, and the opportunities they bring: virtualization for on-demand pay-as-you-go services, dynamic fast scaling as an example. So we would be able, to define, to increase or decrease capacity depending on what is really needed. Slice on demand, adding of service to the slides on demand, service-based allocation to guarantee service, quality of service, and edge computing, of course. And the requirements which they pose is accelerated service length, dynamic scaling, a KPI or event monetization, standardized exposure, and operation automation, of course. Now, now I will move to the part which describes a bit of references and lessons learned by us doing these deployments, actually going through this journey as MDocs. So first of all, I would like to show, we have this as a reference for the project we are doing with Tier 1 operator service provider in APAC, where actually we do implement that network as a service architecture that I was showing on one of the previous slides. So network capabilities then are exposed as services at the design time, including definition of policy to fulfill, operate, and assure, and very important, using the standardized APIs, because this is really key. When you want to move to automation, you need to leverage standardized APIs as much as you can. That would clearly, shorten the processes of deploying new services and interoperability with the different vendors. Then agility to quickly design and launch new customer services using those exposed capabilities by design. And then autonomous approach to ensure service intent is always in a healthy state. Now, the lessons learned, and it was actually mentioned today by several speakers, that it is not only technological change, but perhaps mostly important, the organizational change. That it cannot work more in the silo design when product, network, and IT are disconnected. It has to be a joint journey of product, network, and IT. For example, then those assurance policies are defined and have to define jointly, to be defined jointly between network, IT, operations, and so on. So that has to be a joint effort, and if needed, even some reorganization change is required in order to also apply those, that to organization. Now, the other lessons learned is that automation, we can't say that it is happening now, but it is a staged approach. So we used to have, and this is what we are having now, some manual scripts. For instance, if something is happening, then, there is a need to restart some specific VNFs. We do have that already in the network. That may not be sufficient. So the next stage would be the guided processes in the network. The third stage, and I would say that if I look on the diagram, I would say that now we are somewhere between stage 1 and stage 2. We do realize the need as an industry that one may not be sufficient already. We are targeting towards stage 2. We are not fully there yet. The third one is highly automated network. Perhaps not yet fully zero touch, but highly automated network. And the last one, productized and fully autonomous network, where processes actually are being implemented automatically and autonomously. Now, the free, clearly there is a need in artificial intelligence here. And for artificial intelligence, we actually identify 3 different steps. So the first one for offline data is AI-enriched investigation, where we discover new insight through AI-based data analysis and create manually script automations. The next one is for live network data. For the real-time data is AI-triggered automation. And this is what we are targeting right now. Now, the third one is perhaps the most advanced one, is operational availability, is about perhaps creating some new services and new operation tactics by using AI, not just fixing the problem as we have in 2, proactively fixing the problem, of course, but actually creating new policies based on what we learn from the network behavior. And of course, you know, it is not one approach fits all. Each service provider, each service, each use case requires its own approach. And here we see 5 different levels of approach. So starting from design, from monitoring, when I say monitoring, it is probe, it is performance management, it is fault management, business insight, guided operation, zero-touch operation. Each one of the level would include AI. Each one of the level would become more automated, again, by service providers' needs, by service, by requirements we are getting. Not everything would be needed by each one of the service providers, by each one of the service. We need clearly to identify the requirements and to see which layers it fit and define that accordingly. And as a summary, you know, so basically the approach that I presented is that we have library of best practices and guided workflows, proactive fault performance security and SLA monitoring, closed loop integration, assurance and fulfillment, and that all and other things that we are doing, and that helps to accelerate new service introduction, reduce OpEx, and minimize mean time to repair, of course, and enhance complex SLAs. So this is the journey that we are going through, and we see us going through also, going forward. Thank you.
Thank you, Alla. Do we have a question? Do we have another question? Go ahead.
We need a microphone. Don't want to send us on a wild goose chase here, but you mentioned slicing for service QoS, and we haven't talked about that very much this week so far, but when you say service QoS, are you talking about service from the service provider's perspective, or are you talking about really end-to-end customer experience, and if so, how do you measure that?
So that's a very good question, yeah. So I would say ideally it is quality of experience, not quality of service. And quality of experience, by the way, can only be achieved with autonomous operation and with all those policies introduced per service. Because if we talk about, you know, purely network slicing technology and the way it is defined by 3GPP, it is quality of service. But if we talk about what customer gets, how service works, it is about quality of experience. For that, really, we need all those assurance policies to be provided, KPIs to be achieved per each one of the services. So this is eventually the goal.